All right, welcome to 6.3 day one. Go ahead and open up your notes to that. We're going to add and subtract and multiply radical expressions. Basically, this is at times very similar to just like combining like terms. And so if you know how to combine like terms, then this is kind of a branch off of that. All right, so, and to kind of emphasize that, we're going to actually start off by simplifying expressions just like this. And really what we're doing here is we're just combining like terms, right? Now, how do we know it's a like term? Well, the variable power combination are exactly the same. So here we have 4 of these x squareds, and then we have 15 of these x squareds. And so when you combine them together, you add them up, you get 19 x squareds. You can just treat them like an object, right? So like treat it like a rock or I don't know, any other type of object you want to add together. Then there's no like term with this one, so it just kind of hangs out. If we're really picky about this and the directions say put it in standard form, remember your x cube has to be in front. For right now, we'll call that good enough. All right, so here, where are the like terms? Well, we have an x squared here, another x squared right here, and another x squared right here. Okay, so that's, if we have 4 of them, we take away 3, that's 1 of them. We take away 2, we have a negative x squared. Okay, then we combine our y's together, 5y plus 6y, that would be 11y. Okay, lastly, if we go to multiply these together, 2x times x would just be 2x squared. And then 2x times negative 5, 2 times negative 5 is negative 10x. Okay, so these concepts is what we're going to carry in to using our radicals. Your essential understanding here, you can use the properties of real numbers to perform the exact same operations with the radicals. Like I've been saying, it's basically the same thing. How do we classify a like radical? You know, back here we classified a like term as having the same base and the same power, right? The base power combination. Now, a radical that is a like radical, they have the same index and the same radicand. Okay, unlike radicals, they have a different index or a different radicand. So basically, which ones here have the same index? Well, that eliminates this one because that doesn't have the same index. Okay, now we also need the same radicand. Remember, the radicand is the big number inside of the radical. Well, the 9 is different than the 2's, and so that one gets eliminated, right? So if we were to combine these, well, I guess we don't have an operation, but these are like radicals. All right, so here we go. We have like radicals because they have the same index and the same radicand. So if we have 3 of them and then we add 4 of them, total we have 7 of them, right? So 7 square roots of 2. For this one, we have essentially 1 square root of 7, and we take away 8 of them, so we're left with negative 7 square roots of 7. Down here, let's take a look and see, well, do we have common radicals? Okay, well, first off, we know that this one's kind of an oddball, right? And so let's just actually go ahead and get rid of that one. Not get rid of it, but we're just going to put it out in front and not even think about it. Okay, then, so we're kind of done with this one. All right, now, they all have the same index, but then this one doesn't have the same radicand, right? And so that's the next one that we can write. Okay, so now we're done with that one. These ones have the same index and the same radicand. So if we have 3 plus 1, that leaves us with 4 square roots of 2. And that would be our simplified expression. All right. Next up, here we have to ask ourselves, do we have like radicals? Because if we don't have a like radical, then there's no point in carrying on. Well, they have the same index, right? They're both squared. The radicand inside 7bc, 7bc. Yes, they do. Perfect. Okay, now, don't get thrown off here. We're adding stuff together. Okay, when you add, life is pretty easy. Okay, what's going to happen is we're still going to have, when all is said and done, we're combining 7 BCs together, right? Now, how many do we have? Well, 14A plus 5A, that would be 19A of them. Okay, when we're adding, the A's are like terms as well, right? So we kind of we combined like terms twice in this problem all together. All right. Now next, we ask ourselves, do we have like radicals? And unfortunately, the answer is no. But let's simplify these before we make that decision. Okay, so we know that the square root of 75 can split. It can split into the square root of 25 and the square root of what, 3? So right now we have, this is 5. This term becomes 3 times 5 is 15, square roots of 3. Well, that looks radically different than what this was, right? Okay, so now here we have, this can split into square root of 4. This can split into the square root of 3. That's 2. Negative 2 times 2 is negative 4. Square roots of 3. Interesting, okay. And now 48, what can we split 48 into? I'm guessing 16 and 3. And just double check me on that. Otherwise, I did this video wrong. You can call me out tomorrow for it. The square root of 16 is 4. 2 times 4 is 8. Square roots of 3. Ooh, interesting. So through our work here of simplifying the radicals down a little bit, we all of a sudden have like radicals. They're all the square root of 3. So now all that's left is to kind of add them together. 15 minus 4 is 11, plus 8 is 19 square roots of 3. That would be our final answer. All right. Same concept we're bringing in here. Before you make any decisions, we need to simplify the radicals. All right. And so 28, what can we split 28 into? Probably square root of 4 and square root of 7, right? So this one would be 2 square roots of 7. And 175, we could probably do 25. And let's see, what is 175 divided by 25, I believe is 7. Okay, and so we have plus, oh, hold on, it's a minus, isn't it? There's a minus out in front. So I'm glad that I almost done goofed, because you have to be aware of your signs, and I almost wasn't, right? So we technically have like negative 1 times 5 is negative 5, square roots of 7. Keep a lookout for your signs. You can give me a 1 clap for that almost mistake if you want. No, you don't have to. And I know that only like one of you chuckled, and I'm okay with that. All right. Negative 63 breaks into 9 and 7. Square root of 9 is 3. And so we have plus 3 square roots of 7. Hey, we have common radicals. 2 minus 5 is negative 3. Plus 3. It would be 0 square roots of 7. Well, if we don't have any square roots of 7, then we just have 0. All that work to get 0. All right. Lastly, here we're going to talk about products. Now, this basically it is just distribution. You know, if you remember, the freshmen call it rainbow magic, and you already know how to multiply radicals together. And so, sorry, breaking the video, I got interrupted. So all we need to do is distribute, and we already know how to multiply radicals together. So the square root of 5 times the square root of 3 would be the square root of 15. Remember, your index has to be the same in order to combine the inside parts, right? So 5 times 3 is 15. The square root of 5 times 7, that would just be 7 square roots of 5. Okay, and And that's all you would do for this one. Okay, now for this one, again, the square root of 6 times the square root of 3, that would be the square root of 18. The square root of 6 times negative 5 would be negative 5 square roots of 6. Now we're not quite done because 18 can be split apart. Square root, always ask yourself, can this be split apart? Oftentimes you'll find that it can be. And so the square root of 9 is 3. Oh, hold on. This should be a 2, shouldn't it? 9 and 2 is what it splits into. And so we have 3 square roots of 2 minus 5 square roots of 6. These are not like radicals, and so we cannot combine them. And so that's as good as it gets. Okay, that's section 3, day 1. For the rest of the time here, you need to be working on the assignment. Right now, at the time of this video, Pearson is down, but I trust it'll be up by the morning time, and I'll have the sub put this up for you so that you have the book in front of you. If not, go on to your Chromebook. You can do it. Hopefully it's charged, and then just go to the Pearson website and get it that way. All right. Have a good day, guys.